see your background has changed. You're
Yeah.
either like Tahiti or something like that, or where are you? Are you back?
Exactly. Yeah, in truth, I'm in the south of France at the moment. I'm
Are you
back home.
back? You're back home in the
Yeah,
south of France. So you left
yeah, yeah,
Portugal. Last time I talked to you, you were living in
yeah.
Portugal.
Exactly. That I've had to suspend that work because of the lockdown.
Interesting. Okay.
I'll go
Okay.
back to it a couple of months probably.
Okay. Well, how are things going for you otherwise?
Oh, they're good. They're going great. I'm doing some really cool work with a medical clinic that's going to open in Lisbon in the next month or two. So we're really excited about starting to push that advice out to patients and see what happens.
Interesting. Okay. So are you
Yeah.
learning Portuguese now, or is that something you're picking up?
No, I'm terrible. I've been there since 2018, and I can sort of bullshit my way through a lot of interactions, but I'm not actually fluent in Portuguese, so I just use my other languages to make up for it.
Interesting. Yeah, I'm trying to learn Portuguese since I started doing jiu-jitsu, and that's one of there's a lot of Brazilians that do that. So I'm making an
Oh,
attempt.
right.
So
Yeah, yeah. It's a cool language. It's really nice, but it's not easy. It's kind of like French in that way.
yeah, that's true. Anyway, well, Rafi, for the people that haven't met you, give us your background a little bit. I've met you a few times and talked to you several
Yeah.
times. For the folks that aren't familiar with your work, and you've got a recent paper out I want to discuss a little bit that I think is really exciting. That we had Mickey, one of the co-authors, on, Mickey Bendor, but I mean, you've done other work besides that. And so tell us a little bit about your background, if you don't mind.
Yeah, so I have a master's in molecular biology. I'm a PhD candidate in health sciences at the University of Minho in Portugal. I'm the co-founder of a food tracking app that's sort of, low carb, keto, carnivore friendly. Yeah, I'm now doing some work for this clinic that's going to open up and try to help some people get over a lot of the stuff that our mainstream medicine doesn't really know what to do with and doesn't help prevention wise or any other way. So yeah, that's what I'm about, and excited to talk to everyone.
Yeah, one of the things, and I see, I follow you on Twitter, and you're, like I said, you have a view that's very sort of doesn't match the mainstream narrative, kind of, similar to me, and you obviously have an intensive science background, and so you really try to delve into the science. What are some of the sort of biggest misconceptions do you think that we're getting it wrong on, and why do you say that?
I think that one of the first things that always springs to my mind is people in medicine, biologists, virologists, epidemiologists. We don't use evolutionary thinking enough. We don't use that as a lens through which to filter a lot of stuff. And it's really to our detriment because it's the most powerful idea in biology. And I think if we give it its due, it's a really powerful idea to look back into our past. And that's kind of what we did with this paper, where we were giving the full due of the evolutionary perspective to the question of what did humans eat, because it takes a lot of different fields of knowledge to answer that question. And that's why you have to look at genetics, and you have to look at behaviors, and you have to look at gut anatomy and a million different things. So that's kind of why we went so wide with it there. Yeah.
Let me just delve into that a little more, because there are people out there that think evolution in general is just a theory, and it's a made up idea, and it doesn't have much credence. And I've seen the people that do that. I think there's a decent amount of evidence that would suggest there's that going on. But how strong is the evidence, and why do you think the evidence for? I mean, when you guys did your paper talking about trophic levels in humans, I believe that was the one that you were on. That how did you? I mean, it was more than just it was a number of different disciplines that you synthesized. Talk about the difference, the different ways you brought that together to kind of come up with this theory.
Yeah, so this paper that we recently published was with the first author on it was Mickey, which you had on, and I was just really happy to contribute what areas I was most familiar with. And in my case, it had to do with genetics and metabolism, so we took that, and of course there's Mickey's argument about climate and declining prey. And so many different things to really knot the story together. So we talk about how humans are really fatty primates, compared to the other primates. and how much we use that, and how we fuel our brain, and how our brain needs big fat reserves that we keep in our subcutaneous tissue mostly. We talk about stomach acidity, were we adapted to tubers or not, when even the emergence of fire comes into question, because that kind of tells you what kind of foods we would have been more or less likely to subsist on. So there's really a lot of different things. There's even the age at weaning, that we follow this carnivore pattern, right? So we wean at a younger age, carnivores, and humans do. So, we looked at adipocyte morphology, cranial morphology, the number of copies of genes you had, the sort of essential vitamins, and it could go on and on. The paper was about twice the size. The first draft we had was about twice the size as it ended up being, and it's already 30 pages long. So we had a lot more to say, and I think that's the sort of approach that. That's kind of why I was so excited about the paper, because I think that sort of all-encompassing approach was sort of missing from paleoanthropology, and I think that's why we were able actually to publish in a really good journal the theory that was going basically entirely against the mainstream, that we were this generalist omnivore, when in fact we're arguing we're this specialist hypercarnivore, which is very different. And more interestingly, I hope it sort of catches hold in the field, because I think it can explain, a lot of what we see today in terms of people doing better on meat-heavy diets, and I think it can explain the tropical populations that subsist on way more starch, maybe than the average person in the Ice Age, for example. And I think all those things need to be explained, and they're better explained as hypercarnivores that are specialists. And that was the main thrust of the paper.
Yeah, and just when you say hypercarnivore, that's someone that gets like greater than 70% of their food coming from meat, if I'm not mistaken.
Yeah.
I think that's accepted definition of hypercarnivore. But one of the things, obviously we've all seen the cave paintings. We've all seen the fossil records where human have butchering marks on animals. I mean, that's pretty well accepted. We see some of the radioisotope data that guys like Michael Richards from Max Planck has done. But when we get into adipocyte morphology, cranial shape, bioenergetics, that's kind of a new angle on this. Can you kind of talk us through that a little bit? Maybe put it into layman's terms if possible.
Yeah. So the shape of your fat cells and the size of your fat cells and how you fatten, and all of this is really sort of specific to your species, and there's even some individual variation on top of that. And basically what we see with carnivores is that the energy metabolism of humans is adapted to a diet that's high in lipids and proteins. So this is something that was already discussed in 1985, by the way. So this is nothing new, and it's important because in humans we see a lot of the ability to produce glucose for your brain has to come from fat cells that can give you enough energy, so you can go through gluconeogenesis. And basically, we fit that carnivore pattern, of adipocytes. So yeah, like you said, that wasn't often discussed actually in a lot of the literature. And one of the brilliant things that Mickey did was find a way to bring all of those pieces of evidence together. And sorry, did you ask me about the AME1 genes or something else?
No, I didn't, but we can certainly get into that. I know a lot of people talk about, you talk for the amylase gene copies, that some people will say that, because we have X amount of amylase copies, we're therefore, we're dependent upon starch or sugar or something along those, or particularly starch, I suppose.
Yeah, exactly. So the idea is that, so there was this selective pressure from our environment, which it's hard to identify what exactly, but there was this pressure in our environment to increase the number of AME1 gene copies. And the AME1 gene codes for amylase, and amylase is the enzyme that helps us to break down starch. So we have this gene and it's increasing in copies, and the idea is that this is proof of adaptation to a higher starch diet, and that maybe thus our brains were fueled with more glucose, and has all sort of implications. And actually, when some more modern studies were done looking at the genetics of this, and did people with more copies have less diabetes, for example, right? Because if you can handle starch better, you should be sort of less likely to get diabetes, right? Which is a disease of carbohydrate intolerance. And we don't see that. And neither do we see it with obesity, because we know that carbohydrates can be particularly fattening for people who have a susceptibility to obesity. And yet we don't see them being protected from having more copies of AMY1. So that's something that we dug into, because it was a common point of support for people who were arguing that high starch diet were really representative of humans throughout evolution. We don't think that explains it. I don't know why our copies of that gene increase. It's still a bit of a mystery, but it doesn't seem to be related to diet in that way.
I mean, it'd be interesting to think why else it would be. It seems like that would be somehow diet related. Let me ask you about, because you mentioned the weaning times. I've often referred to a paper, I think it might have been a 2012 paper. They looked at different mammals and their weaning patterns. And you mentioned that humans are kind of the fattest primates. And, we often see pictures of, orangutans, and they've got these big guts, but it's not body fat. It's just huge amounts of intestinal material that they're, intestine that they're processing. But when talk about the human weaning, and how that affects this sort of theory, because we know that humans have bigger brains than really any other primate, and we tend not to breastfeed as long as, say, an orangutan, which is something like 8 or 9 years, and we're typically maybe 2 at most.
Yeah, it's incredible. What the brain has to do to get so big is pretty amazing, and it has to do with ketones and cholesterol. So it uses ketones to make a ton of cholesterol, and it helps it do it quite fast. And so maybe that plays into why we're able to wean like other carnivores do, which is at a younger age, like you were saying. So it's sort of interesting because we're very, very sort of feeble, and we can't take care of ourselves when we're that young, but yet we don't stay in that phase for long. And most of the growth at that point in terms of energy is so much directed towards getting this brain properly developed, and which is going to be, you see these babies with these massive heads, you're like, okay, we understand where the priority is, at that age. And we get off breast milk relatively fast. It's like, 2 years on average. Some cultures do a little longer, but it's basically relatively young.
One of the thoughts I've had is, obviously it's a huge energy demanding time to develop that brain, and just to run the brain, as we know, is hugely energy intensive. And the question would be, okay, if that's true, how are modern babies that are not eating a carnivore diet, how are they growing their brain? My thought is, we now have a way to process, foods in a way that makes them very energy dense, which they wouldn't have been. Like, for instance, the fact that we can eat powdered food now, that we make flour and these things in a powder form, therefore increasing the surface area and the available energy, is something I don't think humans had the capacity to do up until recently without modern machinery. I mean, your teeth really don't create powder. I mean, you chew it into smaller pieces. But so what is the response to people saying, well, my baby got rice cereal and fruit and developed a normal brain without tons of cholesterol? How do we reconcile that?
Yeah, I think that baby got a lot of different things. I think it got a modern hospital, it got access to antibiotics if anything got wrong, got access to a surgeon, it got access to, a lot of modern life to take it to where it can grow up into an adult. But that doesn't mean that there aren't consequences that we might not be able to identify easily or take a lot of time to develop, precisely because it's in the developmental period. So we sort of have to be, I think, a bit more strict with how we approach baby food. And once again, one of the best ways to be safe when you're talking about food is to understand if it's does it make sense from the evolutionary perspective? Like, is this something where we have some degree of adaptation? Is there some way we can measure our interaction with the food? And you definitely can with powdered food and flour and that sort of nonsense, because it changes your insulin response. It changes your incretin system. It gives you gut dysbiosis. Like, this is, pretty measurable. And we know that it's not, necessary when, you got breast milk for a couple years. You can also get, all sorts of meat that's been chewed or ground down to make it easier to consume. Broth. I mean, there's so many things that you can feed a child besides a lot of this crap, because it's really crap. It's oils and powdered protein and powdered plant protein. It's really unhealthy, and it's sort of scandalous that this is being sold and marketed as adequate, when it should be marked like a packet of cigarettes. And if people want to buy that, and if for whatever reason that's what they have to do, no judgment there, but at least the marketing should be honest. It should be sold on that level compared to the good stuff you can provide an infant. So yeah, we need to do way better in that sector.
Let me go back to the fat cell morphology, because if you can maybe, do our fat cells change their morphology or characteristics based on our diet? And I guess that you're assuming that the native state of human fat cells is similar to other heavy meat eating carnivorous animals or hypercarnivorous animals. Can you talk about that a little more?
Yeah. So basically, the adipocyte is your unit of fuel storage, and the way it expands and contracts and how many there are has a great deal to do with insulin sensitivity. And carnivores, as you know, Shawn, they have physiological insulin resistance, which means that basically the body is sparing glucose for the brain because it's producing glucose, and it can do so in a limited amount. And there's a certain amount of tissues that need this glucose to function. And other tissues can use fat or ketones or lactate or something else. So basically, the adipocytes are related to the physiological state in terms of insulin, in large part, and it's also related to sort of the energy needs, and in large part that's determined by the brain. And our brain is very large. So we need to have these sufficiently insulin sensitive fat cells. That's why, when you eat fat, it's these macronutrient that's stored into fat cells with priority. So fat is easily stored into fat, and people take that to mean that means fat makes you like obese, but that's not true. That's just a physiological normal process. Obesity is when something goes wrong with that or other stuff. So the fat cells are typical of carnivores, meaning it's reflecting that physiology, meaning their size is reflecting that physiology, the way they expand, is reflecting that. That's more of a dynamic thing than morphology, but it's still relevant. So that's the way in which the fat cells resemble the carnivore pattern.
One of the, this concept of physiologic insulin resistance or adaptive glucose sparing, some people like to call it. I was chatting with Ben Bickman the other day, who I think has quite a bit of insight into this.
Yeah, he's great.
And he brought up the point that if you give somebody on a low carb diet or a carnivore diet or a ketogenic diet, if you give them insulin, it works. I mean, they get a response, their glucose goes lower. So it's not that they're actually maybe insulin resistant, it's that they're carbohydrate intolerant. So if you give them sugar, the blood glucose goes up, but if you give them insulin, it certainly goes down. So I wonder what your thoughts are on that. And then the other thing is, you mentioned that, we have a very convenient mechanism to store fat in our body when we need it, because we need that reserve to run our brain and whatever else is going on. But then something goes wrong. What do you perceive as going wrong and leading to obesity? Why does, for some people, eating, maybe too much fat lead to obesity?
Oh man, that's a good question. It's hard to say. My instinct is that it's something to do with the regulation of a very fundamental process at the level of the fat cell. So I sort of tend to locate obesity as happening at the level of fat cells. Maybe it's a bit simplistic because, you have too many fat cells or fat cells that are too full, and that's obesity. And you have just way more of that relative to muscle, and that's how we define it. People define it as a weight issue. I don't think that's a useful way to define it. I really see it as a like fat tissue specific biological process. And I think the thing that's broken in it might have to do with insulin and how the fat cell responds to it. We have these factories called the mitochondria, sorry, that are the energy production factories in the cells, and they might not be able to resist insulin properly. And then the fat cell takes too much, up too much of it. And then you have all sorts of downstream consequences where you're trapping fat into fat cells. And that's making you hungry because your brain is not seeing the fuel that it's supposed to be seeing. And you enter this vicious cycle of making up by, overeating. So overeating as a result rather than consequences is the way I tend to think about obesity. I don't know for sure if I'm right, but that's the way I can make sense of it. And what was your first question? Sorry, Sean.
Well, I mentioned the fact that, it was kind of a statement that Bennett had mentioned that rather than insulin resistant, it is actually, if you give insulin to these people, they still get, they still effectively get a response to insulin, and it's more of a carbohydrate intolerance situation.
Yeah. Ben has some really interesting studies under his belt in that area. And I think one of the things that you see there is that in a species like humans or cats or dogs who have this normal physiological level of insulin resistance where glucose is being spared for their brain and some of their immune cells and such, you have there's a very insulin is very sensitive. So the amount that's needed to have an effect on fat cells is actually very small. So you don't need much of a change there because it's you can imagine it as this dam that's being held back, and a small change in it, can really affect how much is leaving the fat cell. And so when you give people insulin, you just shift the whole environment towards fattening, because those cells are so sensitive to insulin in that manner, because that's their job. And when you mess with that, you have these big changes where you have a lot of fat that can accrue over 20 years, and you don't need someone to totally mess something up in your brain or anything. What you need is just something that's sort of tweaking the dial of how much energy you're getting in the fat cell, just so slightly, so that you put away like one extra bite of food than you otherwise would, and that's just accumulating, and you can't control that. Neither can you control it when you're actually eating food that doesn't, or you're not in the obese state. We can't get fat eating just steak. It's not possible, really, to do that. So on purpose, you need something to go wrong. And just carbs are more sensitive to that process because they can change insulin more substantially.
Just a little bit more on the fat cell, because there's two phenomena. There's hypertrophy, where the individual cells just get bigger, and there's another phenomenon called hyperplasia, where you just create more fat cells. And I think there's a sexual dimorphism in there, that women tend to drift more towards hyperplasia, men maybe more hypertrophy. Or are you familiar with what drives one and what drives the other? And many people say hyperplasia is actually better. Having more fat cells is better than having big, large fat cells, because the bigger they get, the sicker they are, I suppose. But what are your thoughts on hypertrophy versus hyperplasia? What drives it, and so on and so forth?
It's a really good question, and it's a subject where most of the stuff I've learned in that area has come from Gabor Erdosi. He's a molecular biologist, so you should definitely follow him for adipocyte and fat tissue related stuff. But I think that we have more fat cells than a lot of other species. And the advantage of that is that when they're small, they remain insulin sensitive. And we need them to be insulin sensitive because we need a lot of them. And it makes sense because we're the fattest primates. And other carnivores have a similar ability, because they also have access to a lot of meat which contains fat, so they need the same thing. But we have such a large amount of body fat that sort of makes us special on yet another level. And the stuff that can mess with a fat cell is often discussed in the low carb keto world as the personal fat threshold. That's the thing that sort of makes you unlucky genetically. I don't really buy into that. I think it's more of a question of stuff like seed oils messing up with the biology in your fat cell, and that's predisposing you to get these fat cells that are going to sort of get really big, hypertrophic, and sort of sputter out fuel at the wrong times and maybe dysregulate your blood sugar in the process and do all sorts of messed up things. I think that's more of what we're dealing with than this genetic threshold that just makes you unlucky. I think there are different ways in which your genetics might make you, for example, become obese in order to protect you from diabetes, right? It can sort of delay it by getting fat, which is sort of a trade-off that you're doing there. So it can sort of protect you from diabetes, but eventually you're just going in that direction, right? And towards metabolic syndrome.
Let me ask you about, your thoughts. I mean, I'm sure you're familiar with like Ted Naiman's sort of work where he's talking about protein energy ratios, and he says that, if you get 40% of your protein, nothing else really matters. And that's a pretty, easy thing for many people to follow. They say, I'll eat more protein. And, people have had success with that. Or there's, in France, I can't remember the guy, the Dukin diet. I mean, that was probably very similar. And I know he was criticized heavily for, and I don't know if I think he's still around. I don't know if he's still promoting that diet. Maybe you have some insight into that. But as far as, is it just all about protein? Do you push back on that theory at all? Or what are your thoughts on that?
I think protein certainly has, it's been beaten down by the mainstream. So it's kind of makes sense that we're all sort of, it's sort of the easy thing to rally around in the macronutrient wars. But in truth, I think that the diet that Ted Naiman proposes, which is really high in protein and basically, not too high in either carbs or fat, and preferably don't mix them together. If I get that right, so you're trying to aim for a high protein to energy ratio. That's sort of the way in which he explains it. You can get a lot of good diets by following that framework. So in that sense, I'm totally on board with it. Though what I tend to sort of quibble with is that it's more of a simple rule, like a heuristic. It's not actually like scientifically accurate in terms of what's happening, because you can't make an equivalence between carbs and fat, right? You're calling it to protein to energy ratio, but you're not saying to what? To carbs or to fat, because they're not the same. Because we've seen from clinical studies that when you decrease your carbs 10%, you get a benefit in total daily energy expenditure, meaning you tend to sort of burn more calories ever so slightly naturally. And that can easily be extrapolated into a big fat loss advantage over the long term, which is sort of the holy grail that we're dealing with, because it's always about these short-term comparisons. But long-term, you need something that's going to work whilst you're sleeping, whilst you don't need your discipline. It's just going to work, right? So I think the theory, if that's what you want to call it, or the diet perspective, misses that part out, because I think that's substantial. And then it's also saying that basically if you eat fat and starch together, for example, that's inherently fattening compared to if you had them separately. I don't think that's particularly true either, because once again, what is the starch and what are the fat? Are you telling me seed oil is equally fattening as stearic acid? Because I don't think it is. And I don't think that flour is equally fattening as energy, let's say, from berries, which has sort of sugar and fiber, and you're just limited in how much you can get. So it's sort of these things that I take issue with, but I get why it's simple and why there's an attractiveness behind it. And I think the diets are going to work for a lot of people. I'm not entirely sure how much of it is the protein, because I know for some people in which just increasing the protein, they just haven't lost weight. I've seen it with my own eyes. But my bias is actually that most of the time, just increase the protein and maybe lower the fat, for example, or the carbs, and that should help. But it just appears not to be the case for everyone who tries it. So at this point, we don't really know, and people should just happily try both. But if you sort of start demonizing fat, you can't do that easily. That's why it's kind of missing the forest for the trees. I think just just see it in that way. So yeah, don't try it, just experiment, like kind of like what you say, Sean, like just try it.
Yeah, you know, and I guess to be fair to Ted, you know, he takes overall calories and basically says that, you know, if you can get, you multiply protein by 10, and if it's more than,
Right.
it's more than the overall calories, then you've got 40% or more of your calories come from protein. So it doesn't matter. Carbs are, you know, it equalizes carbs and fat. But, and you're saying there's an advantage. Now, that's a controversial statement, even though, I mean, I follow the work of David Ludwig, and he's produced several studies sort of maybe corroborating that. There's people that push back on those. I know Kevin Hall pushes back pretty hard against that. And there's this whole, you know, there's definitely a pushback between that. And so what, I mean, as far as when you say that, I mean, I think most people would concede that protein has a thermic effect that's higher than carbs and fat. I mean, I don't think that's even the least bit controversial. So I think when you put more protein in the diet, you kind of get some free calories is the way I look at it. And Ben Dickman says, I don't even count protein as a energy source. I mean, you know, not that it can't become one, but it's very difficult generally, unless you're just eating a pure protein diet. But then when you get into carbs versus fat, this is where everybody sort of bickers and fights about that. And so where do you, I mean, where do you come down on that? And what are the evidence that shows you that maybe there is a somewhat of an advantage by reducing carbohydrate relative to fat?
Yeah, I think it's sort of, you can take that question at a different level. So on the really sort of most, if we're looking at the level of Legos and we're looking at the cell and how the electron transport chain works, which basically extracts all of the energy from your food. At that level, you know, your metabolism can run on glucose, it can run on fat. So at that level, we definitely have the machinery for both, but it's from that to know if that's going to make you equally healthy long term, that's a different question. And that's harder to answer. Now, I just tend to default to what I know, which is evolutionary theory. And that tends to sort of tell me that fat might be the safest option. But there are some arguments where, you know, depending on the quality of your carbs and, you know, some other aspects like your immune system, and if you can handle them well, because of course they tend to be more problematic in terms of the immune system, because a lot of carbs come from plants, which are, you know, where we get 99.99% of our natural pesticides from. So it's clear that there's something we need to watch out for in that case, whether that's traditionally or even in modern times. We have to have selectively bred food. We have to have food that's been processed in a certain way, so to be made less immunogenic and problematic in that regard. So there are inherent disadvantages to plants for people who have, well, for the only species basically that's managed to change its environment so much that these sort of changes where you can switch between plants and animals sort of with some flexibility, that's becoming harder when the population gets sicker. So I think that's why you tend to see people defaulting to something closer to carnivore, which is just lower in carbs and plants, because it's kind of easier. You do away with a lot of the stuff that you're more likely to trip over once you're, you know, you have a developmental disadvantage maybe over a generation because of some environmental toxins, or, you know, your mother was diabetic or something disadvantaged you in that regard. So I think that's why, you know, more meat, less plants is the direction that makes sense given what we're seeing and how humans are adapting. So for fat loss specifically, because that's sort of more interest, I guess, generally, you can do it many different ways. But once again, I think you're gonna find most people having an easier time when they can just eat nutrient dense food, which happens to be calorie dense, which is of course you know, blasphemous to say, but you know, animal food is calorie dense and it's nutrient dense. People tend to do well eating a lot of that for their fat loss. Then what they add on top of that or how they modify it, you know, that's sort of secondary importance. But I think it makes sense even in that regard. And yeah, the macros things is difficult. You know, ketosis is an interesting state, but beyond that, you don't need to be keto to lose fat. That's for sure. But it's certainly an interesting state to regulate your appetite.
Let me ask you about, you know, I've seen papers about talking about perhaps type 2 diabetes or insulin resistance was actually an evolutionary strategy to deal with ice age times and stuff like that. Have you seen that particular theory posited before? And if so, can you comment? And the other thing is that I've seen people talking about, prolonged exposure to animal products, meat and, relative infrequent meal leads to a state of glucagon predominance, and you become hypercatabolic, so to speak. And you can somebody, and Stephen was asking about hypercortisol issues, and with underlying problem sleep apnea causing cortisol. Is there a concern about too much glucagon long term, and then how did humans survive it? Was insulin resistance perhaps a evolutionary adaptation to the ice age?
Yeah, I think that our insulin dynamics certainly have to reflect that environment at some level by necessity. And the question is how would it be reflected? And you would want a body that can do most of what it needs to do without glucose. That's why our muscles are so happy working on fatty acids and recycling glucose into lactate and back to glucose, and using our fat stores to keep that whole thing rolling. And glucagon is really just helping us in that process. It's just one of the helpers. And it's when it gets dysregulated, what it can do is strip a lot of muscle off of you, and dysregulate your blood sugar. And diabetes is often, framed as this balance between glucagon and insulin, these sort of, these levers that are pulled. So I think that they have a lot to do with the ice age environments, and they're reflective of what we see, because a lot of even the drugs that are being developed are trying to target glucagon and insulin, usually lowering insulin or increasing the sensitivity of some tissue to insulin and glucagon. You want to sort of keep that down, suppress that pharmacologically speaking, because that's what's going to shoot up your blood sugar. So yeah, those things have to reflect each other. And it sort of always brings you back to the evolutionary lens there. And the successful researchers sort of incorporate that in their work, I think, at some point.
Yeah, I'm just seeing discussions in the chat about talking about overeating fat versus overeating sugar. And, there are people, we saw in the particularly early phase of keto, people were just downing sticks of butter, and, people were able to demonstrate they were able to do that. I mean, and again, I don't consider butter to be a evolutionary fat source. I mean, we didn't domesticate animals till about 10,000 years ago, so surely we didn't have butter. So, I mean, when I look at fat sources, I look at the fat that comes in an animal, the meat itself. And so, I don't know if you want to comment on that, but it's something that, yes, you get nauseous if you eat too much fat, but I think if you ate pure sugar to a point, you'd also feel bad. I don't know. What are your thoughts on overeating fat?
Yeah.
Because most people don't eat butter or eat straight sugar. It's ice cream. It's some mixture, and those tend to be the hyperpalatable addictive foods, to be honest. Cookies, you can donuts, cake. Those things tend to have fat and carbs, which is something that Ted would say, and that type of stuff.
Yeah, I think it's a good question. I think what's happening there is not necessarily the combination of the macros. I think it's a combination of the processing that's sort of key. So if you think of the perfect fattening thing that you want to devise, you'd make it from flour. So that would start off by imbalancing at the level of in your small intestine. It would start by jacking up the incretins that are gonna make you super sensitive to insulin from the amount of carbs. So for a given amount of carbs, it's just going to produce more insulin because of the format in which those carbs were delivered to your stomach. And then you're going to want to make sure that you're as sensitive to that insulin response as possible from the point of view of your fat cell. And what you need for that is omega-6, linoleic acid. Now, if you can combine both of those things, like on one hand, you have this dial that you tune up the insulin secretion with, and on the other dial, you just tune up the fat cell sensitivity to insulin and ability to take up fat and glucose and whatever. Then you've got the perfect recipe to make someone fat. And I think what we see like downstream like, oh, he's like, we can't control it, they're overeating, and it has all these addictive behaviors, and even like like behavioral issues like ADHD, like a whole lot of things can come from that. I think that's secondary in terms of what makes people fat. I think that then they just tend to overeat because that's what happens when you make someone suck up more fat than they would otherwise would. So I don't think that I think satiety is just resulting from that. It's not a cause really. So because there are so many combinations of, for example, like if we just take the easy example of the Maasai, who might have access to milk, they could have access to meat, and they could have access to honey. And there's no reason that they can't combine these things throughout the year, actually, given the seasonality of things. So they might get a bit bigger if they're purposely trying to overeat, right, for some ritual or whatever, but they're not going to get obese. Like they're not, their percentage is going to waver within, like being super ripped to just being ripped, but they're not going to become obese. And to get obese, to really get to that state where it's just totally out of your control, you need to just to mess things up at a fundamental level. And I don't think it's just the satiety messing up. I think it's the fat cell that's breaking it.
One of the interesting things, and I think it came out of either this paper or another one that Mickey pointed out, he points to around 80,000 years ago, we saw this shift towards, a different style of hunting and food gathering. The megafaunal animals were largely sort of going away. We lost some of the access. We ended up eating smaller animals. We eventually turned more to plant foods and eventually to agriculture. And a lot of people, that are in the plant-based sort of camp, they'll point to some studies from 30, 40,000 years ago. They'll be looking at coprolites, which is basically this fossilized human poop, or dental erosions, and say, well, look, these humans were eating grain. Is that purely a product of time frame? Is it, if we go back, not 40,000 years, but if we go back 200,000 years, does that stuff go away? Does that make sense there? And what was the shift towards, what was the driving shift towards changing our dietary pattern as human beings?
Yeah, so the question of when you're like, how do you quantify the amount of plants and animals in a diet? You sort of have to do a lot of indirect measures, and one of the ways that people have used to do that is look at the teeth and try to determine, for example, the wear on the teeth that's going to indicate what is grinding. Is it grain? Is it a bone? Is it rock? That's how you can sort of determine it. And then there's also what gets stuck in the teeth. Is there pollen on that site or on that fragment that we can link to whatever? It's a lot of indirect stuff, and most of it isn't actually quantitative. It's qualitative. Is there something? Yes or no? Not how much is there, and what was it used for? Was it used for medicine, or was it used for food? And there's all these other layers of interpretation. Now, something that's open to less interpretation is stable isotopes, for example. There are limitations on that. There's some level of difficulty, but it's very consistent. And you can test the isotopes in modern hunter-gatherers and compare to pastoralists, and to modern people. And you can have everything line up that you're looking at that came from 150,000 years ago, for example. So even though it's limited, we can do a lot of other, we can strengthen that level of evidence. And when you look at it that way, you see that plants do have a disadvantage in terms of they tend to disappear more easily in terms of the remains. It's easier to find a skull or something like that than it is to find plant material. So there's an inherent disadvantage there, but if it was what we'd expected, is this to show up in the stable isotope data, right? If the stable isotope data was suggesting, no, look, their bones are full of these atoms that are suggesting that they're eating plants and not animals, then we'd be like, okay, maybe we're getting it wrong, but it's not. We're seeing that, we're, as carnivorous, if not more, than wolves are. And like, how carnivorous is a wolf? I mean, that's basically, it just eats meat. So I don't think it's a stretch for us to be, hyper carnivores. It'll be interesting if we can get better accuracy for like specific tribes and be able to distinguish, well, maybe they were more like 60% meat and instead of 80%. I don't know if we'll ever get to that accuracy, but I would like to, because I would bet you would see some differences that might explain why we're so flexible in our diet ability even today.
Some people mention something, they'll talk about maybe the aquatic ape sort of theory, or the fact that we were coastal and we would have depended upon seafood for our brain development. There's an interesting, this radioisotope. Again, I mentioned Michael Richards has done much of the work with, European Neanderthals and early Homo sapiens, and showing what you showed, hypercarnivory. But he's also done some work in the Pacific Islands, which I thought was kind of unique. And he looked at some of the, in the Pacific Islands were kind of developed later. We were one of the last places for humans to settle. But looking at those folks, it showed that, interestingly enough, the isotope data suggested they were eating pigs, and they were feeding fish to the pigs to fatten the pigs up for some reason, even though they so what are your thoughts on the essentiality of fish in the human diet? Was it essential in us developing our brain, or what's the evidence point to with that?
Yeah, I think maybe this is a bit of a very common sense perspective, but I don't think you need fish to live. I think lots of people have lived without fish pretty successfully. But have people lived mostly on fish or only on fish? I would bet, yeah. I mean, there would be so much opportunity. The water, the globe is covered in water, and there's rivers everywhere, and we're clearly super smart. We're able to get a lot of fish for very little effort, actually. I mean, you can get a lot of calories with fish, and I don't know how dangerous it is compared to hunting mammoths, but I'm guessing it's all maybe not as dangerous. So there's definitely a lot of reason to believe that we relied on fish. I think a lot of the question about fish is about omega-3s, actually. That's kind of where the conversation goes, because no one is talking about differences in like TMAO in the gut dysbiosis, that, fish is even higher than meat in some measures there. Like, no, that's not of interest to the general conversation. So it's usually about omega-3s. And it's kind of interesting because omega-3s is sort of a darling of every diet group. I think no one doesn't like omega-3s, right? But it's really more about the omega-6 in my mind, in the sense that if you have a very low omega-6 diet, maybe under 5%, 4%, 3%, that does so much for your health, most likely, as far as we can tell. It's really impressive, and you don't seem to need all that much omega-3 if your omega-6 levels are low, which is kind of good news, because it means that you're not constrained to eat a ton of salmon, for example, which is maybe not that great for the environment as well. And that means maybe you can focus mostly on beef, which is also much better for the environment. So sometimes we get lucky, I guess. I love fish, but it's not something I eat because I feel I need to. It's just something that I enjoy. So that's kind of how I see it.
Yeah, and I just I looked at one of the things, popular population groups we always talk about, like Inuit, and they are obviously coastal in many cases, living on islands in Greenland. They have access to you'd assume they'd have access to plenty of fish, and yet they still chose to eat marine mammals, seals, caribou. Mm-hmm. So I don't know I don't know how hard it is to fish in the Arctic. I'm sure that's relatively difficult, perhaps, or I guess they're cold. They're cold no matter what. I don't think hunting a seal is any harder than fishing, quite honestly, or easier. Mm-hmm. So, let me ask you, because we talked a little bit about omega-6s and omega-3s, and yes, I agree the absolute amounts are not that impressive that you have to eat so much to meet your requirements. But this goes to, the question about lipids and fats and cholesterol driving heart disease. What are your thoughts around that sort of sentiment? I've seen a lot of people that go on, keto diets, low carb diets, carnivore diets, and their LDL cholesterol will go up, and they'll be worried about it. And, generally it's in the context, I've lost 50 pounds and I feel great and I've never felt better, but my cholesterol's high. How do you sort of assimilate that information?
Yeah, I think the LDL perspective, or the LDL hypothesis of heart disease, some call it the gradient hypothesis, some talk about LDL particle number and not LDL cholesterol. I really don't care. I think it's all bullshit. I think you should not worry about your LDL cholesterol in terms of your heart disease risk. Now, it could be interesting to measure it because it could tell you something about your fat use and your metabolism and how you're using fat. It could give you hints about your immune system. So it's cool. Measure it. It's awesome. But I would not be driven by fear of LDL cholesterol or LDL particle number or ApoB or sort of the BB gun theory of heart disease. I think it's a lot of nonsense, and it's taken up so much space and oxygen in the research world. It's done such a disservice to people. Worrying about a 20 milligram per deciliter increase in LDL cholesterol or even a 50 milligram per deciliter increase, and not paying attention to all the other markers that are improving, fat loss, memory improvements, mood improvements, migraines, epilepsy, on and on and on, allergies, all the other things happening, but there's an increase in cholesterol, and we're not going to support you in your recovery anymore. I think it's been a scourge in research, it's been a scourge in medicine, and it's still alive and kicking. It's terrible.
Yeah, and I wonder, I mean, the cynic, sort of suggested there's still a lot of money to be made in driving cholesterol down lower through, statins are losing their patents, but now they have the PCSK9 inhibitors, which will, I'm sure, take their place as it can continue to create a lot of wealth for that. Let me just ask one thing you kind of alluded to, being locked out of Portugal due to coronavirus. I don't know what's going on in France versus Portugal. Are they not letting you travel between countries right now? Have you sort of been impressed with our response to this pandemic, or any thoughts around the way we're handling this sort of situation currently?
I think it's funny because I always thought, in the back of my mind, man, maybe I'm kind of an extremist. I mean, I always say that the guidelines have been the biggest public health mistake ever. Maybe I'm, being hyperbolic, or, maybe I should, measure my words more. And then the damn lockdowns happen. And then I'm like, man, when you think it can get worse, when you think we can't mess things up further and not learn from our mistakes, we do the biggest unintended consequences blunder, again, which is we're just going to close down the globe as best we can. We're going to force people inside when we have a coronavirus, which even in the early days was known to be transmitting inside and was highly susceptible to UV light. And now we're learning it's 8 times more susceptible than we thought. So our mistake has just been, multiplied by that much. And we're going to suspend social interaction, which has all sorts of terrible effects for the immune system. And we're going to, further decrease people's level of vitamin D, and we're further going to incentivize shelf-stable food, which is, usually crap food and not fresh stuff that you can get from a butcher's or something. And the poorest people are going to suffer most from this, not the laptop working at home class like myself or a lot of other people, right? We're not going to suffer that much from it in those terms. So it's just a terrible decision all around. And yes, and then get 80% of the discussion lost on masks, which are just ineffective for what we want them to do. I mean, they have a restricted particular use in certain settings by certain people under certain conditions. They make sense. Under what we wanted to do with it is prevent spread. It's a fantasy, and it's just amazing that it's been heralded as sort of this obvious necessity. So it's a pity we wasted a lot of time and resources, and I just hope that we can start to regain some trust in natural herd immunity, and with a bit of luck the vaccines are going to go well, which is a whole other story. But yeah, it's been really bad, and never like before. I think people need to understand the implications that their metabolic health has for how they can handle a pandemic, or how they can handle these really difficult conditions. So I hope it'll kick people into gear to take some personal responsibility for their health and see that they can't necessarily rely on institutions like we all wish that we could, because no one wants incompetent institutions. We might want different institutions, but no one wants incompetence, and that's what we got. That's maybe the only thing most people can agree on in terms of the response. So yeah, it's not the brightest of pictures. Sorry.
Yeah, I mean, when you talk about unintended consequences, and again, I don't know how accurate this is, but I've seen reports that the average American, for instance, has gained something like 29 pounds of unwanted body weight during this 1 year long situation. Wow. Which clearly just I mean, in response to host susceptibility to infectious diseases, whether it's coronavirus or anything, has really worsened. And it's only going to, if we think about the relationship between obesity and cancer and diabetes and heart disease and all the other things, I mean, we've only made them worse. And I mean, one of the problems I see is once people, and many people have lived this, once you gain all this weight, it's a very slippery slope because you don't feel as good. Everything hurts, you're inflamed, you don't feel like exercising, then you just kind of, you've started all these people that maybe weren't on that journey into that journey. And now we're going to see this probably going to be affecting people for many, many years to come. And I think that's another one of the disappointments from all this. What is a sense of, I mean, I don't know how many people you interact with or talk to, but I mean, is that the general consensus is we kind of screw this up, or do you find many people, because we do see the United States is particularly polarized, particularly around politics for whatever reason, not completely, but there are many people that they're just like, if I'm a Democrat, I'm for this. If I'm a Republican, I'm against it. But what's going on in Europe and, France, Portugal? Is it similar, conservative, liberal type of thing, or is it just everybody's sick of being locked down, and what's the status there?
I think one of the similarities with the US, with Europe, is that the dividing line in many respects might be authoritarians and not, because there's a million different ways to come to an opinion on these really difficult questions, right? But there's usually a sort of defining attitude of authoritarianism, or people who are more geared towards freedom and informed choice and all of those things. And I think that's the scary shift that's happening in Europe as well as in the US. The US is always interesting because it has so many states that tend to get these really better controlled experiments, like we saw with Florida and Texas compared to California and many other places. So I think it's pretty clear that seasonality has a ton to do with the patterns that we're seeing. I don't think masks have any effect. I don't think lockdowns have much of an effect except make things worse, and mostly in the long term. I don't think we've seen much of the wave at all, actually. I think this is mostly very short term. We're seeing longer term, we're going to see problems probably related to inflation and such, but that's another topic. But Europe has really fallen prey to it as well, and Italy has capitulated first, and it's shameful because my father is Italian. I used to live there a few years back, and it's a shame to see that we just decided to copy the approach of the Chinese, which is there's a whole philosophy behind the Chinese approach of controlling the population. And that healthcare can be healthcare measures can be handled by locking people in their homes. And we were like, yeah, what those guys are doing, that's what we're going to do. And that's just so crazy that it really took a lot of time to sink in. And then it sort of spread to the rest of Europe, and that public health approach came to the States, and we took all of the focus and all of the resources away from the stuff that we could actually change, right? If they were going to be coercive, how about coerce us towards better food or whatever? But of course it also was coercing us towards the most terrible things that we could do for our health. So it's in Portugal, where I'm going to hopefully be able to go back to in a month or two. The lockdowns are over, and they've actually released the state of emergency, which a lot of countries haven't done. So that's to their credit. Giving back power is very rare, very difficult, especially nowadays. So that's a good sign for Portugal. I don't know what's going to happen to France in that regard. They're more conservative with their approach. So hopefully by the summer, we'll have outside bars and stuff be commonplace. And it should happen in a couple of weeks. Some cafes will reopen with just, terraces on the outside, stuff like that. But, nightclubs, forget it. I don't see that coming back.
Yeah, it's interesting. Sorry to hear that. Hey, Rafi, tell me what do you have come? I mean, assuming you get back to Portugal, what are you going to be pursuing? What's the next what's the next thing you're going to be working on? Just to get an idea what's going on.
Yeah, so at the moment, I'm just trying to navigate the lockdowns to get my PhD finished. I've got some stuff to finish up there. And in the meantime, I'm working with a medical clinic in Lisbon, the Perro Clinic, that will be in Lisbon. And we're going to, apply a lot of the stuff we talked about today. So that's my most exciting thing at the moment. And, the app that I made with my team is still online at nutrita.app. People can check that out if they want something a little different in terms of just calorie counting nonsense. This is something a little more interesting. People need an app, to motivate them, give them some structure. But yeah, otherwise it's mostly, finishing that PhD and working in the consulting with the clinic, basically helping them with their research and all of that, and probably get some results to show you, Sean. I'll have something to brag about soon.
Yeah, looking forward to it. Hey, Rafi, thank you again for doing this. And I think it's Sunday evening there where you're at, but can you just, for people who want to follow you, I mean, I think you're, I like seeing your stuff on Twitter, but where do people go to find out more about you?
Thanks, Sean. It was really cool talking to you. People can find me on Twitter at Raphael S7 with a PH. That's where I do most of the science and discussion stuff. I'm not really on Instagram or most of the other platforms. So that's Twitter, and the app is at nutrita_app on Twitter. So that's where most of the stuff is happening. So thanks for inviting me, Sean. It was really fun.
Yeah, well, next time, just anytime. We love having folks on here that provide good information. I know there's a lot of topics we could go in detail, and you have a wealth of knowledge. And so thanks, Rafi. Have a great rest of your Sunday, and hopefully we'll chat with you.
Thank you.
In the near future, hopefully in person one time again. That'd be fun. So
yeah, please, let's make that happen.
All right. Okay. You guys have a great rest of your weekend, and I'll see everybody tomorrow. Take care, guys. Bye-bye.